Hello again, everyone, and welcome back to what I hope is our last e-learning class to focus on the second part of nuclear energy. Now, last time we talked about how nuclear energy is used around the world, its effect on the environment and our bodies, and today we're going to look at the two types of nuclear energy, nuclear fusion and nuclear fission. So to begin, let's just understand what is nuclear energy. So nuclear energy comes from the nucleus of an atom, the center of an atom. And we on Earth here use uranium, specifically uranium-235, in nuclear power plants because the atoms of uranium-235 are easily split. They're easily broken apart. Now, I want to make a pretty important distinction because we touched on this before when we were talking about the different types of energy. So, nuclear energy itself is considered a renewable energy source, even though the material used, uranium, is considered a non-renewable energy source because it is limited. Okay? So big distinction there. Nuclear energy as a concept, as an idea, is a renewable energy source. The material used, uranium, is non-renewable. So again, we've got two different types of nuclear energy processes. The first is fusion. Okay, now let's wait for this GIF to start again. So here we've got two subatomic particles, okay, and they are going to be squeezed together. They're going to be fused together, and boom, we have fusion. When they combine, they create new elements, helium and perhaps an extra neutron. The other is fission, where we take a neutron and we fire it into a nucleus. When we fire that neutron, there we go again, neutron into the nucleus, it's going to break apart, all right, through fission and create two fragments, okay, along with extra neutrons, okay? So these are the two processes of nuclear energy. Let's look at them specifically. Our first one is nuclear fusion. This is energy that is released when the nuclei of atoms are combined or fused together. Okay, they're brought together, fused, combined, added together. This is how the sun produces energy. So, the process. As gravity pulls hydrogen and helium atoms together, a star forms. Remember, during the Big Bang, hydrogen and helium were created, and their coming together due to gravity forms a star. Now this pressure combines or fuses hydrogen atoms together and produces more helium. Through this process, through this fusion process, heat and light are created. We can see that here in a moment. When they are combined, boom, we've got the fusion, the heat, and the light created. Okay. Now, the product produced by one reaction, okay, let's say the helium produced, is the starting point of another reaction. Okay? We're going to look at that in a moment. But I want you to understand, this is how stars produce heavier elements. Okay? That's how we go from hydrogen and helium to carbon or lithium or iron or gold. Okay? It's through this fusion process. Okay? Now, the process here is repeated. I don't have to go over it again. But I want us to look at that first picture there. What we see on the left is we've got two hydrogen atoms, okay? And they are fused together, and in the process, they create helium and another hydrogen atom. When they are combined together, we get photons. Photons carry light, if you remember. And we get another helium atom. When the helium atoms are pressed and fused together, combined, boom, we've got more hydrogen, more helium atoms. Okay? Now we can go down the line. Perhaps we're squeezing more hydrogen and helium subatomic particles together to form lithium or gold or iron or neon, whatever it may be. All right? But this is how we create heat, we create light in stars, and how heavier elements are produced. Now, on the other hand, we've got nuclear fission. Now, nuclear fission is what occurs on Earth, okay? We cannot right now create nuclear fusion on Earth. Only fission. So nuclear fission is energy that is released when the nuclei of atoms are split or broken apart. Nuclear fusion is used in nuclear power plants to generate electricity. So, how does this work? Well, a neutron is fired into a uranium atom. Okay, like boom, like a gun. That neutron is being fired into the uranium atom. When the uranium atom splits, it produces radiation. Now, this causes a chain reaction. What do I mean by that? Well, I mean that once one atom is split or broken apart, released neutrons begin to split other uranium atoms. And then those neutrons will split more uranium atoms. And then those neutrons will split more and more and more and more. This process just repeats continually. Okay? This whole process, though, could be dangerous if it weren't contained within a nuclear reactor. A nuclear reactor protects against disaster. Okay? Now, the next steps here, all right? 4. Radiation heats water to produce steam. Okay, so through this fission process, as neutrons are being fired into the atoms and breaking them apart, it's producing heat. And this is heating water, producing steam. Now, while the steam is being created, the water is also keeping the uranium cool. If the uranium gets too hot, we could have a meltdown. So the water is not only generating steam to create electricity, but it's also keeping everything cool enough to avoid a meltdown. That steam then, for step 5, as we know, drives a turbine and a generator to produce electricity. So again, I have repeated the steps here, but I want us to look at that picture. Okay, we've got the nucleus of an atom, of a uranium atom, and we've got the neutron being, boom, fired into it. When it's fired into it, that nucleus is going to break apart. When it breaks apart, we see it releases energy in the form of heat, and we've got fission product left over. Okay? Let's just say smaller pieces of uranium. We've also got extra neutrons that are released. And those extra neutrons are going to be, boom, fired again into other fission products, other pieces of uranium. This is that chain reaction. Okay? They're going to break the nucleus or the fission product apart. New neutrons will be released, breaking more apart, firing more neutrons, breaking more apart, and so on and so forth. Okay? That's how we get this process to continually occur, continually creating energy, continually creating electricity. So, that's the difference between nuclear fusion and nuclear fission. Please make sure you complete the attendance questions. If you have any questions or want to know more, please ask in the forum or ask me when we get back to school. Okay? Thanks so much. I look forward to being back in class as long as COVID doesn't increase or anything happens there. Have a good day.